Okay, I think the next session is then Katia.
Yes, thank you for absolutely amazing introduction into what we are doing and how to get use of it. I think that it is probably a good time to summarize it and to try to understand how can you use all that. Actually, the point is that PyPSA-Earth is not only a model, but also a data management concept. We do have an integrated data workflow, which helps you to obtain all the data which are necessary to build your model. So we solve here two problems. First, that is problem of data availability, and second, that is problem of data cleaning. And actually, the most of the workflow models are focused exactly on this task, on extraction, preparation, and making data fit to be used into model. But we recognize that the things can easily get overcomplicated. And fortunately, we have a solution. At the moment, there is still quite a knowledge base around PyPSA-Earth. And in a couple minutes, I will try to show you how can you use it. I would say that we have three groups of knowledge. First of all, that is where Max started. That is where the tutorial was from. That is the most systematic, the most, scientific-like source. That is read the docs. The second point, there are Jupyter notebooks, that is Hackathon, and actually notebooks with code and outputs and comments. And that is a place when you can explore and find, hopefully, a lot of inspiration and a lot of useful pieces. And last but not least, it is community. That is something which make any open source project alive. So what can you find in each of the group? In read the docs, there are installation guides, there are different how-to instructions, namely how to customize your workflow, how to fit your workflow for another countries. There we have collected software hints, which mean there are different tested approaches to install this one or that one. And we are collecting frequently asking questions to which are not fitted into each of the categories, but which are very useful and they should be systematized. So if you have any ideas, they're very welcome here and also in other places as well. As for Jupyter notebooks, here you can find Hackathon materials. We will in a minute look into it to understand how can you have some practical exercises with PyPSA-Earth. And you have examples, usage examples, which you can use to explore, to understand, to analyze your model, and which can be very useful if you need to present the results. And as for community approach, there are different channels of communication. About Discord and GitHub, you have still heard. Besides, there is also a YouTube channel. You may look into PyPSA-Earth channel itself, and you may find quite a very useful presentation when looking by keywords PyPSA and Europe. And if you want to be kept informed, then LinkedIn page is the place which you may want to check. So the usage area, read the docs, that is where based systematic information is collected. Jupyter notebooks are may be useful to get into details of the data and results you obtain. And community, that is a great thing to keep in touch. And now let's go into project. Do you see my browser now?
Yes, I can see it.
Fantastic, very good. Then here we are on the PyPSA-Earth repository page, project page. And here you can find all the repositories it has. So if we will go into the main repository, it contains code. And here is a link which brings you into read the docs. Sorry, that was something went wrong. Sorry, it was tag due to Zoom. Oh, here we are. So there are introduction instructions. There is introduction. There are installation instructions. There is short tutorial about how to get started. That is more complicated, more advanced tutorial on how to customize, how to change different configuration parameters in the config file Davide has shown. There is explanations on how to use SnakeMake power. There is explanations on how to fit your model to the custom area. Actually, the data workflow is pretty well automated up to moment. And the one thing which you should care about is to build custom cutout. Cutout, it is a concept of processing climate data. Cutout, it is just an archive, climate data archive, which contains data on the climate parameters relevant for energy simulations, cut for an area of interest. Besides, there are some hints on how to validate and an invitation to contribute into the documentation. We have described also the data which we are extracting along the way. And it is worth to mention that probably each group of this data, especially grid topology data, is useful by itself, even not as model input of a particular PyPSA model, but well, if you have some problem trying to understand what is going on in power system, that may be a very good idea to use PyPSA-Earth workflow to extract data from OpenStreetMaps, data on power grid, and to look on what is going on. With climate data, we rely on the last generation ER5 reanalysis, and we also rely on global data on different environmental factors. And there are some economical parameters which we use as assumptions. You may always check and modify them. Now let's go into the PyPSA-Earth main project and look how can you use documentation. Documentation consists of actually hackathon part and of notebooks part. First, let's look into hackathon. The most basic part relates to working with Git. Actually, well, this code can make life much easier, but in case you have any troubles with Git, it is worth to look into how all this can work. The next hackathon notebook explains what is the architecture, what is the main parts of the PyPSA-Earth. That is explanation of how can it be used. and detailed description of the main parts we are laying on. And actually, that is the workflow. There are parts of download and filter data. And because thanks to modular construction, modular design of PyPSA, we may take interim output of each after each stage and use this data and analyze this data and probably, if needed, to modify. And sometimes that is very useful. The next Hackathon notebook explains in detail how to install. Probably you may find it useful to remember what was told today about installation. And likewise, how to execute notebook will help you to remember what Davide has explained. So don't hesitate to look into it. And how to debug, that is also technical and very handy notebook. And finally, how to incorporate new regions. Here we briefly describe main principles and main steps which you need to keep in mind when customizing the problem to be solved on the region which you are interested in. Actually, that should not be complicated to move from tutorial to real world example. You just need to select, to change a couple points in the configuration file and to generate the cutout, this climate archive. And that is important. Don't forget to check that this new cutout file is also correctly represented into the configuration file. So the cutout building may take a bit long. If you remember about building cutout for China on the previous step. So because climate data we are using are represented on a mesh with about 25 kilometers cell. And when you are requesting, by default, we are requesting 1 year when it is not tutorial, and it takes quite a while, but it's worth it. I will show how do we use climate data and how do we calculate renewable profiles and renewable potential. And now, I think that is the most interesting part of our documentation. There are notebooks and in particular validation notebook. Well, how to use it, that was explained by Max in the first part. I just quickly remind that the most straightforward approach is just to clone both repositories, the code repository PyPSA-Earth and documentation repository, into the folder, let's call it PyPSA-Earth project. And then you should be able to execute each of the notebooks locally on your computer. So, and here is my local copy. Here is what the PyPSA, what Jupyter notebook looks like. First of all, we are doing some technical stuff, importing packages, setting visualization parameters, setting folders. And here begins interesting part. We load the solved network. Here we will look into net zero Saudi Arabia study, which was done by Anas. And I think it is quite a unique thing. That is Anas' master work. So let's look how decarbonized future for Saudi Arabia may look like. You may see here these warnings. It means nothing bad. Actually, that is just the model being a bit verbose. So don't be scared when you look such things. If it is working, then everything is all right. And actually, the network object has a built-in flat function, which we may just call and look what our grid structure looks like. Here is an isolated bus which relates to the issue Max has mentioned. We are working on that. And here is the more advanced visualization function, which helps you to look into the details of this optimized model. So actually here, thickness of lines and size of buses is proportional to load in lines and buses, and it gives you a little better understanding on what are the power flow in your power system like. So actually, that is camera-ready picture, which you may use to discuss, and I will show how to recreate this picture for the custom model, for the model you need to analyze. And further, there are some analysis, some technical calculations needed to look into spatial structure of generation. If you remember, Max has shown how to look into time series, and this visualization example helps you to understand what is going in the space dimension. And what we see here is that the decarbonized power system of Saudi Arabia may be based on solar mainly, and there is also need in good part of battery inverters. He is the legend. And actually, this big part of inverters, big part of batteries makes the system quite expensive, and it may be tackled by another approaches. So you may use embedded statistics function of the network object and look into economical and operational parameters for each of the carriers and storage technologies you are using. And you may go into more details. And now let's look into how to recreate this notebook for a different country of interest, for a different study. I will just duplicate this file and let's use it for, not for Saudi 2060, but for Nigeria 2020. So that is a path to the model. And here we should replace one thing with another one path with another one, and then to restart the notebook kernel, to run the simulation from the beginning, to clean up its environment. Here, the picture has changed, and actually we have this info and warning again. And here we also have absolutely different things. And here it looks like we need some adjustment. Actually, that is quite a usual situation, as when your notebook was adjusted for one problem, you may need to do some little adjustments if you want to tackle different one. So what would be great? It would be good if we could have a little bigger buses, which means that this bus factor should be smaller. Let's try it this way. And here we do not recalculate the whole notebook, just recalculate some cells. Oh, that is much nicer. So that is how you can use notebooks. And a part of optimization notebooks, there is also quite trying part of modeling process, namely validation part. And that is also a part where our accumulated experience of modeling can be useful for you. Let's look. There, as you can see, the folder itself is called validation, and it is intended mainly to compare the assumptions and the data which are inside the model, underlying assumptions and underlying data, compare it against independent third-party data. And for Nigeria case, let's look on how can we validate that we understand that the power grid model we are using is relying on more or less correct data. Actually, there is path to raw and to clean OSM extracted data. A quick reminder, OSM, that is OpenStreetMap project. That is the biggest global coverage project, which collects georeference data for anything you may be interested in. And it contains also data on power infrastructure, which we are loading into raw files and clean into clean files. So, and a part of that, we have country shapes, the geographical data, which we are loading from geo-administrative shapes server. And actually that was the server which is sometimes not working. Actually, that is, this loading part is a part of modeling chain where something sometimes can be broken, not because of your fault, just because, well, that is real life, but usually it is, well, it is repaired in course of some hours or some days. And there is also solved network, which we will use in these validation examples to get information about power demand and generation. Again, here is some technical stuff. And here are attached data on reference data on power grid in Nigeria. There are data on power grid topology from transmission system operator. And there are some numerical data. First of all, let's look how our network grid model looks like. We read its geometry, sort voltages by levels, assign some colors for visualization, and plot it against OpenStreetMap landscape data. So there is color coding for lines of different voltage class, which are overlaid over Nigeria, realistic Nigeria map. And the main output of this picture is that outline of the network looks quite similar to what TSO operator has. So we may say that quantitatively, that qualitatively, that by the shape, our network looks very much like how it is in reality. There is one more visualization approach, which may be quite useful, especially if you're struggling with some topology issues. That is HV plot, which allows you to zoom your map. And one small remark, this HV plot actually doesn't work good from inside notebooks. That is why this code is commented out, but you may save outputs of this interactive plot, save it as HTML, and to use this HTML when exploring interactively what do we have into the network. So there are comments regarding similarity between network layouts, and there are quantitative calculations of line length. And what we were caring about is first, if OSM cleaning, if cleaning of the OSM data doesn't lose any sufficient information, if we don't have shrinking line length when we clean data. That is just a technical check when we ensure that coordinate system was a right one. That is some technical fixes which are needed to recover some missed OSM data. So it may be that there is no data on lines tag on I mean, in OSM, it may be no data for lines, but it may be data on cables, and it is possible to recover, to calculate, to estimate lines length using this cables line. Sometimes it may be not so accurate, but anyway, that is much better than nothing. That is statistics by classes of voltage and estimation of total length for raw and for clean data. And actually, as I remember, the losses were not very high, but there was a consideration which related to quite a considerable differences between the OSM extracted lines length and TSO reported ones. Actually, OSM data has given higher value for the whole Africa, but in particular for Nigeria, OSM estimation was lower than TCO data. But again, that is much better than nothing. And as in Africa, situation with data availability is especially tricky. That was quite a success. And further, we will look into demand data. For this purpose, we are using solved network and extract time series of demand to process them and to obtain estimation, which is quite close to the current Nigerian electrical demand. And by this, using the same approach, actually the reference data for energy mix. And there is a question. If you could read question, I would be very grateful. So here we have statistics for generators, which was extracted from solved network data. And here we, by data science pandas magic, we obtain here again some warnings from one of the packages, which is not very meaningful. And here is the table which we need. And again, the results are quite decent. So that is the validation notebooks, which we invite you to explore. They were developed in course of some practical simulations, and they may be not perfect from tutorial point of view, but they exactly correspond to the requirements and to the challenges which you are facing throughout your modeling journey. So there is also quite large collection of notebooks, and a part of tutorial and validation, there is also one additional class of problems which you may be interested in. Namely, you may be interested in exploring what are the output of each of the rules you're executing. It may give you better understanding on what's going on into your model, what are the assumptions, and it may give you some useful data if you are interested in them. So here is, actually, we can, indeed, you can use possibilities, use options of this C code if you need to quick visualize and to look or to look into CSV. But if you need something more advanced, you're welcome to use notebook. For example, these notebooks explore what do we have when we have executed build shapes rule. That is a rule which composes country and coastline shapes files, and which collects and calculates geographical administrative shapes. That was China here. It is what looks the whole picture like. And that is picture for absolute value of the population with overlaid data on power grid. So this, there are, I believe, clean data on substations and on lines. And that is what power grid of China looks like. Here it was quite strict, quite strict condition which I have set for voltages classes to make this picture more representative. Otherwise, it will be too complicated and too heavy. And there are population density across different administrative regions. And finally, there is cost. Well, that is, these shapes are needed to calculate how can we use offshore wind power. And if I still have time, then let's look on what our climate management looks like. Here we will quickly look into outputs of built renewable profiles. That is the main concept of dealing with climate renewable, with renewable relevant climate factors. And we use the profiles are calculated using cutout data for each of the technologies we are setting into the config. And by default in config, we do have photovoltaic and 3 different kinds of wind power. The profiles for each of the technologies, for solar and for wind, are being calculated using quite realistic technical assumptions and restrictions connected with land use. and with the reserved area where no renewable plants can be built are also taken into account. Well, and here we will explore the profiles which were calculated using cutout data. There are X-ray archives, X-ray datasets, and here is how can we visualize them. So there is cutout mesh, and there are a little nicer plot rasterized according to discretization of reanalysis. And this notebook land use availability, it takes us into the logic behind accounting for land use availability. Here we are looking on Nigeria in this renewable climate factors notebooks. That is Nigerian shape, and that is plot of the cutout, which means that is exactly the area from which climate factors were extracted. And to account for land use restriction, we use Copernicus data on land use types. And we also have a special approach to account for reserved data. So that is reserved natural areas where no renewable plants can be built. And that is what we have for Nigeria due to after some calculations using excluder and raster approaches. And as we can see, these land use restrictions for Nigeria is quite important because only half area can be exploited for renewable development. That is rasterized picture, and that is a little different approach to availability metrics. And these pictures, I think the concluding one, show the key concept of renewable potential aggregation in PyPSA. Namely, here we have Voronoi polygons, that is polygons which are built around each node in such a way that all the points inside each polygon are closer to the node of this polygon than to each other node of the network. So in such a way, we aggregate renewable potential and account for its spatial variability. So, and that is what can you, that is approximately, that is a possible approach. How can you use notebooks to understand and to get use of the workflow and of the underlying data? So I think that is time to stop, and probably that is worth to remember why are we here now. And well, thank you for your interest. We will be so you're very welcome as users, as contributors. We are actually in an active stage of development, and your feedback and your participation would be can really make the difference. So many thanks, and I will be happy to answer your questions.
Thank you so much, Katia. Now it's the time for questions. So are there, Shreya?
Hi, thank you. Katia, my question is, it's not a question. I wanted to know a little bit more about the demand data that you talked about.
Oh,
so
the the demand data are then calculated by a machine learning approach where predictors are temperature, population, and the main GDP, and a number of different economical parameters. And the main challenge to build and to learn to train such a machine learning model was that we need to global scale. We need a tool which could work for any country of the world, and it has been tested, and it looks like it for the countries we have considered. It looks, I would say, surprisingly well, considering all the uncertainties into underlying data and the global scope. So, and well, and it is also worth mentioning that the model is not running each time you run the PyPSA workflow, PyPSA-Earth workflow, but demand data were pre-calculated. There is some restrictions connected to it because there were climate years and there were years of SSP scenario which were used to calculate these demand profiles. But the good side is that you still have these demand profiles, and you may explore them actually even without need to run PyPSA-Earth model.
Thank you. A follow-up question is, nowadays in IPCC report, they are talking about reducing demand through efficient use of instruments and stuffs. So we can change. So we can create more scenarios and change the demand profile in the PyPSA
Yes,
model.
absolutely, absolutely.
Thank you. This is
and actually, as far as I know, thank you for the question. Actually, it very much aligns with our development line, because there is, as far as I know, there is still one more, at least, demand projection tool into development, and we will be very happy to have more.
Great. Thank you.
Thank you so much.
Particularly, you can create interfaces very easy. In fact, in the snake file, we saw the inputs and outputs of each rule. And if you want to use your own data, you can just change the link, the input link to your own file, obviously provided that the same data format can be used. But you can, for example, run a tutorial so that you have the sample files for all the files that you are interested into, and you may just need to reproduce one of the files, obviously with our support.
Okay. Thank you.
Welcome.
Thank you.
Are there any other questions? By the way, I shared also a paper on the demand prediction approach and how we tuned it a little bit and what we're planning in future. So you can also get involved in some of the open source developments. All right, let's give people a little bit of time for questions. It's always a weird break. Like, do you think it's possible to create a screenshot,